Bismillahirrahmanirrahim. My name is Muhammad Sabur Ahmed. Hello everyone. In this video, I'll be discussing chapter 1 from the book C++ Programming, from problem analysis to program design. This chapter introduces the basic concept of computers and programming languages. Before learning how to write C++ programs, it is important to understand what a computer is, how it works, and how programming languages are used to communicate with it. This chapter provides the foundation required to begin learning C++ programming. In this chapter, we'll be going through 11 topics. So, our first topic is types of computers. Computers are categorized into different types depending on their capacity, performance, and purpose. Supercomputers are the fastest and most powerful computers available and are mainly used for advanced tasks such as climate modeling, scientific experiments, and space related research. These computers are extremely expensive and are generally operated by government or research organizations. Mainframe computers are another category and are commonly found in large institutions, institutions like banks, railway systems, and multinations companies. They are capable of processing massive amounts of data and can support many users at the same time. Many computers fall between mainframes and personal computers and earlier used by medium-sized organizations. But today they're mostly replaced by highly performance servers. Microcomputers are also called personal computers, PC, are most widely used computers and include desktops, laptops, tablets, and smartphones that we use in everyday life. So moving forward, our second topic is hardware and software components of a computer system. A computer system functions through the combined operation of hardware and software. Hardware includes all physical components of a computer such as keyboard, mouse, monitor, CPU, and a storage device. Input devices help in entering data, output devices displays the result, and storage devices store information either temporary or permanently. The central processing unit, known as the CPU, plays the most crucial role because it controls and processes all instructions. The CPU consists of the control unit, which manages the execution of instructions, the arithmetic logic unit, which performs mathematically and logic operations, and registers, which temporarily hold data during processing. Software is a collection of instructions that guide the hardware. System software manages the overall functioning of the computer, while application software allows users to perform specific activities like writing documents or using the internet. Our third topic is language of a computer. Computers do not understand human languages and can only interpret machine language, which is made up of binary digits, namely 0 and 1. This is because electronic components in a computer operate using two states that represent these binary values. As a result, all instructions must ultimately be converted into machine language before execution. Machine language is very difficult for humans to write and understand, as it involves long sequences of binary numbers. To reduce this complexity, programming languages were developed so that programs can write instruction in a more understandable form, which can later be translated into machine language. Evolution of program languages. Programming languages have gradually developed over time to simplify the programming process. In the beginning, programmers wrote instructions directly in machine language, which was fast but extremely complex and difficult to debug. Even a minor mistake could cause serious problems. Later, assembly language was introduced so to replace binary instructions with symbolic codes, making programming slightly easier. However, Assembly language still depended on the hardware and required an assembler to translate it into machine code. To overcome these limitations, high-level programming languages were created. These languages are closer to human language, easier to use, and allow programmers to develop soft and efficiently. Moving forward to our fifth topic, high-level programming languages. High-level programming languages are designed to be easy to understand and use, allowing programmers to focus on logic rather than hardware details. These languages provide simple syntax, better readability, and easier debugging compared to low-level languages. Examples of high-level languages include C, C++, Java, and Python. C++ is particularly popular because it combines the features of procedural and object-oriented programming. Programs written in high-level languages are also portable, meaning they can run on different systems with minimal changes. Compiler and its role. Compiler is a program that translates code written in a high-level programming language into machine language so that the computer can execute it. The compiler reads the complete program, checks it for errors, and then converts it into an executable file if no errors are found. In C++ programming, the compiler plays an important role because it ensures that the program follows the correct syntax rule. If errors are present, the compiler reports them and the program must be corrected before it can be run successfully. Understanding a C++ program. A C++ program follows a standard structure that helps the compiler understand how the program should be executed. It usually starts with preprocessor directives that provide instructions to the compiler, such as including required libraries. The main function is the core of the program as execution always begins from this function. Within the main function, various systems are written to perform operation like calculation, input, and output. The program ends with a return statement which signals that the program has completed its execution properly. Knowing this structure helps programs write organized and error-free programs. Processing of a C++ program. So while going through all these 11 topics, we have already covered 7 topics, and our eighth topic is processing a C++ program. So before a C++ program produces output, it goes through several stages. First, the programmer writes the code using a text editor. Next, the preprocessor processes the directives included in the program. The compiler that checks the program for error and converts it into object code. After successfully compilation, the linker combines the object code with necessary library files to generate an executable program program. Finally, the program is executed and the file runs, and the program displays the output and error during these stages must be fixed before execution. So that was we discussed the processing of a C++ program. Moving forward, we have algorithmic and problem solving techniques. An algorithmic is a logical sequence of steps used to solve a specific problem. It helps programmers plan the solution clearly before writing the actual program. A well designed algorithm is easy to understand, finite, and effective in producing correct results. Problem solving in programming involves understanding the problem, identifying required inputs and expected outputs, designing an algorithmic implementing the solution in code, and testing the program thoroughly. Using algorithm al- algorithmic using algorithms improves program quality, and reduces error. Structured design and object-oriented programming methodologies. This is our 10th topic of the chapter. Structured programming is based on dividing a program into smaller functions and organizing the code using control structures such as sequence, decisions making, and loops. This approaches this approach makes programs easier to read, debug, and maintain especially for smaller applications. Object-oriented programming focuses on organization programs around object and classes rather than functions. It uses important concepts such as polymorphism to model real-world problems effectively. C++ supports both structured and object-oriented approaches, which makes it suitable for a wide range of applications. The last topic that we'll be covering in this chapter is different type of C++ languages, which is standard C++, C++11, and C++14. To maintain uniformity and portability, C++ follows standards defined by international organizations such as NSI and ISO. Standardized C++ ensures that programs can run on different systems without major modifications, making software development more reliable. Later versions of the language, such as C++11 and C++14, introduced new features and enhancement that improved performance and simplified coding. These standards made C++ more modern and efficient, helping programs write better and more code, maintainable codes. So this was our chapter that I explained all 11 topics in this video.